Most of you know how to graph parabolas from their description. I give you a vertex, I give you a point, and you can graph it. We're going to get two other shapes now, ellipses and hyperbolas. And they both use the same strategy. The basic graph of an ellipse works like this. You have a containing box. And that box holds a deformed circle, a circle that has been squished, if you want to think of it that way. And it has no points. I don't know if you've ever squished a balloon. You don't get points when you press the balloon in. In nature, things try to be as smooth as possible, and most of you will quickly come up with a shape that makes sense. But what's going to help you when you sketch this is you're going to try to keep this here and here, and we'll see what these here and here's are, and here pretty flat. And then it reaches over and connects like that. So let's do some sketches on, let's make sure I have enough paper for 2 rounds. Okay, here's how to think of an ellipse. To begin with, think of an ellipse, that's great, as starting from a given center. Get that off the paper. So we'll pick a center to be located at 4, 1. So mark 4, 1 on the first graph screen. 4 over, 1 up. The next thing that's important about an ellipse, and what distinguishes it from a circle, is that it has uneven radii. So the radius, there's a radius in the x direction, and write like this, r sub x. And let's say the radius in this case is equal to 5. So you come to the center, and you count out 5, put a dot. Count out 5 in each direction, put a dot. And let's say the radius in the y direction is 6. So you come up 6, put a dot, come down 6, put a dot. Now you're about ready to draw the containing box. The containing box goes through here, goes through here, goes through here, goes through here. Okay, check with neighbors, make sure they're doing the same thing you are. And I'll be looking over just to see if you have the general shape. It's very important that you keep. Okay, now that you have your box, make a sort of slight, very shallow plate here, 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 because I want to emphasize there's no points in an ellipse. And then try to make a smooth connection everywhere, as smooth as you can make. It's not an edge shape. It's not fat in filling the corners. It's as smooth as you can get all the way around. And let's see how good you are at achieving this. Now, I'm not going to be really grading your artistic skills. What I would like you to at least spend close to this. Okay, that's pretty good. Okay, that's cool. Shall we leave it? That's excellent. All right, so you all have the general idea. What you're graphing is the orbit of a planet around the sun, or a moon around some planet. So, one of the things you want to keep in mind as you draw an ellipse is that you don't want to be on a planet that's doing this. Oh, I'm changing my mind and go this way. I think if you're on the planet, you might feel a certain amount of discomfort if when it got to these key points, you went, oops, no, no. A lot of things would bounce around if you were making that kind of journey. The same thing is if you're going like this, and you go, oh, no, oops, change your mind. Okay, so you're not going for a TV set view of the universe. You're not going for this. Basically, you want to experience a very smooth journey where you don't notice any changes in direction. In fact, there are no changes in direction. To an outsider, you're constantly in a different place, but from the center here, if you focus on it, it's always a smooth journey with the same amount of leaning. Very few planets, very few moons travel in perfect circles. Their orbits are distorted by other planets, gravitational fields from other places, and perhaps the original path goes on when it started moving. But nature does not like sharp changes. It doesn't make sense that something would suddenly say, oh, I don't want to be here and I want to be there. Now, as you get into quantum thinking, there's some weird things I'll share with you sometimes about physics and changes in location that seem to turn this into a lie. But on the mega scale, on the large scale, things want to be smooth. So keep that in mind as you draw your sketch. Now, what I would like you to do at this point, now that you've drawn your ellipse, is erase the box. Because the box is simply to provide a guideline as you draw this. And I want you to see the ellipse without the container that created it. That is the ellipse.
Will we ever be able to do this without the box? Or do you
Some students are, they can. This is always your own choice as to whether you want to do it without the box or not.